Hi everyone, welcome today. So my name's Lee Gilmore and I'm a serverless advocate from the UK. And today we're going to be talking to Suresh Mathew about the challenges with automated systems and the rise of autonomous systems and how they can help SREs. So welcome, Suresh.
Thank you, Lee. Thanks for having me here.
Excellent. No, it's great to talk. I'm really excited about chatting through this today. So is it worth just giving a little bit of background to yourself and what you've done at PayPal? Because I think that's really interesting. I think definitely a good place to start.
Yeah, I was at PayPal and eBay, that family, for the past 12 years, leading infrastructure and SRE platform teams. Built an autonomous system at PayPal that is still powering the production.
Okay,
Now, 2019, off to Sedai, the autonomous platform for SREs.
perfect. No, that's great. And obviously, you're a massive fan of autonomous systems. What is your experience with working with SRE teams and kind of automated systems in the past?
Sure. So, Lee, if you look at SREs as a term or as a job, right? It started probably in the 2000s. Started with tens or hundreds of services. Now, with 2015, 2014, I would say, with microservices, now 1,000 services are probably common in a mid-sized company,
Yeah,
right? And Kubernetes was probably an aspiration before, but now that's real. Everyone is using it.
yeah,
Serverless was a thing that was just doing batch before. Now look at it. It is powering everything. Probably the first use case itself is a real time application. So things have changed a lot. And if you look at most of the technology that was helping them, AIOps platforms, they were all built to give dashboards back to SREs. They
yeah,
can look at things, they can observe things. Observing was enough when it was just services, but with microservices at this scale, you need more than observing. In fact, that dashboard, condensing that dashboard itself is a new set of technologies now.
yeah.
Now, what do you think about AIOps platforms generally in your work, right? In serverless world?
Yes, that's interesting. Obviously, as you've said, traditionally you would have, domain services that were, powered by containers. Now in the serverless world, you've got many domain services which are made up of many different AWS services, and just the cognitive load of understanding what's going on across all of these different services within a domain service and across an estate that is, so difficult. It's just alert overload currently. I would say personally, yeah, I think it's difficult for teams to see what's going on at the moment. Definitely,
Exactly. If you look at the release velocity today, right? One of the recent surveys says most companies release every minute, probably even more than that. So AWS says they release every 11 seconds, and Facebook does more than 700 every day. So that's a lot. So it is, I think, time for something newer, something different than just a platform that helps to a platform that can be a buddy.
yeah, that makes sense. And obviously, like, what is autonomous? How does that help?
Yeah, one challenge that I see generally is autonomous and automation. They rhyme, right? It
Yeah,
in fact they have nothing in common. Autonomous is automation plus smarts, and anytime anyone talks about autonomous, they are really talking about the smarts part of it.
yeah,
Let's take an example. So automation was basically created to keep or make things simple. Instead of clicking 10 buttons, you now click one button. That is automation in very simple terms. Now, when it comes to application monitoring, You have an application, you pick a metric, say CPU, you pick a threshold, say 60, then you put a rule there saying if it's more than 60, then you put an action there saying restart, reboot, replace, scale up, scale down, right? And you stitch everything together, you get an advanced automation or IFTTT. Now sprinkle autonomous here. Sorry, sprinkle intelligence here. You get an autonomous system out of it. You pick the metric CPU when it was automation. Here you let the system pick the metric for you. You pick 60 as a rule. Now you let the system pick the threshold for you. You pick the action, you let the system pick it. So in other words, it starts deciding on its own.
Okay.
That exactly is the deal. So in two lines, if you say, typically automated systems are told what to do, how to do, and when to do. Autonomous systems are told where to look. The system figures out what to look for and what exactly are the rules.
So I guess what you're saying is it's almost fairly static, these rules, and you're talking about some kind of intelligence. Does that take into consideration things like seasonality, for example? What kind of intelligence are we talking about? Is it user behavior? How does that currently work?
Yeah, if you look at the seasonality aspect of it, typically rules come handy to some extent. For example, you have traffic from 11 to 1. You pick a rule that says at 11 scale up and at 1 scale down.
Yeah.
You know where the problem starts? What you are essentially trying to scale up itself is changing because that release is happening. Your rules suddenly go invalid.
Yeah.
Right? So it becomes the job of SREs to really change these rules all the time. And if something don't, in fact, something fails, right? It's not going to be on the system that it's put. It's really on the scaling part. That's why I said rules fail when it comes to modern systems. You need to think differently to operate on a modern system.
Okay.
Yeah, automation, I think, in my mind, failed short at that point.
Okay. And obviously, we've talked about your thoughts around autonomous systems. So how would you even start building an autonomous system?
One thing I can tell you is it's hard. It's extremely hard.
It sounds it.
It is in fact easy to write a white paper about it, file a patent, but to build a system that can be deployed into production, that can be trusted, right? You are really trusting, handing the keys to the kingdom to the system
Yeah.
with your customers, your production, with everything, right? That's hard to build. Now, there are three key tenets to this problem. One, safety, which is pretty obvious.
Yeah.
If it's unsafe to proceed, stop, retreat, call for help. Two, the context. What is the traffic coming in? What are the dependencies? How exactly things flow in, right? Now, this context is easy to build for given an application, but different types of application or the whole system, you need the whole context, right? The third aspect, which is measuring efficacy, we can roughly divide it into two parts. One, did my remediation help? The second part, did it hurt?
Okay.
Did it help part is fairly straightforward. You saw a problem with a metric. Let's call again simple example. Let's say CPU was 100 when you did something. Now after you do that, CPU came down to 50 where it was before. Yes, it worked.
Yeah.
Now, did it hurt? That is interesting because now you have to look in the neighborhood, not just in your application. Because when you restarted, a lot of things can really go haywire.
Yeah.
That's when things get interesting. Think about a case where you had even stateful dependencies. Now you cannot even measure with the golden signals, you have to go out, right?
Yeah.
So that is why something that appeared super trivial now became extremely complex. It's going to be the case with the other two use cases as well. So it's hard to build one. That's why we built one, so you don't have to build.
That makes sense. Yeah, that sounds massively complex. A lot of different inputs, a lot of, I guess, moving goalposts that you need to think about. So, okay, so, we've kind of covered that. Why should we go to kind of intelligent systems? What are the main benefits that we would see?
Lee, here I would say again three main reasons for that. Right. The first one is release velocity.
Okay.
You don't release anymore weekly. You release almost on a daily basis.
Yeah.
Sometimes split seconds, sometimes minutes. Right. That's one. Second, the microservices or the dependencies that's coming in. Services are becoming smaller. Dependencies are now very interesting. So it is extremely hard now for an automated dashboard to give you the insights that is actionable for you. It's hard.
Yeah.
The third aspect is scale being a common problem for everyone. Scale used to be a problem only for the Facebooks and the Googles and the large banks and the large companies, right? Now look at a mid-sized startup. They do billions of transactions. When I say transactions, I'm not talking about just the money transactions, but billions of transactions between services,
Yeah.
right? So that's very common. Now, those are the three main key drivers that calls for an autonomous system. And that's where AIOps really fails.
Okay. No, that's great. So obviously, if I was to, with my teams that I work with day to day, if I was going to kind of start looking at, bringing up these conversations in this transition to intelligent systems, where do I kind of start with that?
Yeah, I would say the key source for you is data.
Okay.
When it comes to operating SRE production, I generally say there are two things you have to keep in mind. One, it's a big data problem. That's one. Second, you need to know that ML and AI have been failing for the past 10 years to do everything it promised. So you have to be very careful in picking the stuff that you cannot put in a production system,
Okay.
right? So you start with the data, get the data together, use the algorithms to start giving recommendations. That's the first step.
Okay.
Because the hardest part is really executing it in production. That's the hardest part. When customers are really interacting with the system, you're letting a system without human intervention handle something, which is hard,
Yeah.
right? So you start with recommendations and think about or validate this. If this recommendation had come in at this time, would I have executed it? Right? If the answer is yes, you have a good autonomous system. So that's how you start building on it. That's a building block. And now the hardest part is again figuring out the efficacy of the system, making sure ticketing can happen, mutual exclusions, and things like that. So there are other aspects, but that's how you start. Then you move slowly towards the actions. Maybe it starts with the simple scale ups or the scale downs, but move towards complex actions. So that's how I would start with.
Okay. And would you say, obviously, people watching this, if they're SREs, for example, they might be thinking, look, this is going to kind of take over my job, so to speak. What are your thoughts on this kind of move to intelligent systems, and how would that affect these kind of roles?
In fact, I love this question. In my mind, if an autonomous system were to take your job, in my mind, you should not have your job.
Okay.
Think about the compilers, right? Did any compiler ever take the developer out? No, there are smarter compilers. There is no way. Imagine, okay, let's take a Tesla as an example. I think that's a good example here. Your navigation systems give you directions from place A to place B. That's useful. That's super useful, right? It did its job, and we have all been using it. Now, think about the autonomous car by Tesla. It takes you from place A to place B, taking those lefts and rights, right? Accelerating, changing lanes, all autonomously. remember, it calls for help when needed. It promptly does that. Second, to answer your first question, the driver is still in the front seat. So there is no way you can build a system that can take humans out, right? You
Okay.
can only help improve their quality of life. If Tesla had ever attempted, that's my strong belief, Tesla had ever attempted to release a level 5 autonomous car into market, I think they would have been still building it. Right?
Makes
There
sense.
are decisions that you have to let humans take. And the SREs who are driving in production, they need time to spend with their families, which means they don't want to take this left and right. That's boring. They know how to do that, right? They don't want to be blamed when they're not on time when they get a pager at midnight. Come on, right? They need a good night's sleep. They have to spend time with their families. So that is what an autonomous system gives. It's not taking that job out, it's really making that job a lot more comfortable, enjoyable.
Okay, so
That is
you're
what it
essentially
does.
saying more productive, I guess you could
Exactly.
say.
Exactly.
You're freeing up for more productivity and I guess more features for end users.
Exactly. In
Okay.
fact, in my mind, there is threshold should never ever be set. This alert should never be sent, at least not at midnight. Right? You don't want your teams to have those rough conversations anymore.
Yeah.
You really want an autonomous warrior who can really fight for you. So that's my take on SRE systems. In fact, that those are the two big reasons for us to build Sedai. Right. SREs can be late. They don't have to manage thresholds. They have higher order tasks to do. They have control loops to write too.
Yeah.
They also deserve a good quality of life. They need to spend time with their families.
Yeah.
That is exactly Sedai's vision. That's why we built Sedai. Like Tesla is to cars, Sedai is to us, site reliability engineers.
Excellent. And obviously, you've kind of whet my appetite to find out more about kind of intelligent systems and obviously Sedai. Just before we close, how can the viewers of this find out more information about Sedai? What's the best way to do that?
Two options. One, check out our booth in the conference itself or visit our website www.sedai.io.
Fantastic. That's great. Well, thanks a lot for your time today. Really enjoyed chatting to you.
Thank you very much, Lee. It was nice.
Thanks now.